All right, so I hope everybody's doing okay today. On Friday, we went ahead and reviewed chi-squared again. We're starting to wrap it up. Went through another problem, showed you on the calculator how to go ahead and do that. And I'm going to go ahead and do it again today with another problem. And I'll let you guys decide if you want to work it by hand or if you just want to go strictly with the technology. I'll leave that up to you. But then I'm going to go ahead and give you the rest of the period to work on your assignment, because you definitely will need the calculator in order to go ahead and finish it. Because I think a lot of people only got to 2 last time on Friday. Is that right? Okay. So we'll do that today, and then tomorrow we'll come in, we'll go ahead and grade it. And then I want to go ahead and talk about some limitations, because if you're already planning on using chi-squared test for independence on your IA, there are a few things you want to be aware of that could potentially happen. Was it? Oh, you didn't see those? Yeah, those are cool, right? Actually, nobody said anything about those today. They are, right? My kids and I painted that one yesterday. Fun. It's cool. Thank you. Thank you. I'd never found a Batman one before. I was like, oh, we got to go get it. I love the Spider-Man. It's pretty awesome, yeah. See, so I have DC and Marvel. So 9 and 6. Mm-hmm. Okay. All right, so just a couple of items before we get through this problem here. The first exam is going to be in a week on Monday the 8th. So I actually put the finishing touches on it this morning. The only concepts I'm putting on there are going to be the Pearson's correlation coefficient. So we need to be able to find R. We need to be able to find the regression line, use it to predict, and will that be a reliable prediction or not, based on what we've been doing. And then the other aspect is going to be chi-squared. Okay, so we will definitely start the next unit this week, though.
I have a question. I'm so confused on how we're able to tell whether our prediction is reliable.
It depends on if the value is within your data or not. Like if your value is within your range of data, then it's probably going to be pretty reliable if you have a strong relationship. But if it's outside, even if it's a very strong relationship, then you have to say, no, even though it's strong, we don't know what's happening outside the set of data that we've got. Mm-hmm. Yes. Mm-hmm. That's exactly right. Okay. Let's see. Also, there won't be any tutorials in the morning from 7:45 to 8:05 because what's happening next week on Wednesday? We got the PSAT, right? And I was one of the lucky ones chosen to administer the test. So, by law, every year, if you're going to give tests like this, you have to be trained and sign off on it. So that is where I'm going to be in the morning. So I will be here for a little bit after school today and tomorrow if anybody doesn't finish, wants to come in and use the calculators, or if you just have a question. And then we're going to move the quiz this week to Wednesday. Normally on Thursday. It was on Thursday, and I don't believe I've changed it on the website just yet. But we are going to have it on Wednesday. It's going to be a chi-squared quiz over that material. That way I can get it back to you, and you'll have another resource that you can look over in preparation for the exam. Other than that, I think that's everything I have, unless anybody has a question. Gabby? Oh, you were just giving me a thumb. Okay. Anything? Yeah, so this Wednesday, so a couple days from now. Yes. Okay. Good. Okay, well, let's go ahead and run through this guy real fast. It looks like we're comparing gender, male and female, to 3 types of sports: badminton, volleyball, and table tennis. Okay. So what we want to go ahead and do is first get our totals. Yes, ma'am. No, this is just something I put together real quick before the bell rang, just as an example. So there's no copies of this. You can just follow along. So let's go ahead and make my row and my column totals, because we're going to need the grand total to continue the problem. So let's see here. Of course, the 40 and the 20 will give me 60, 20 and 15, 35, and then 10 and 15, 25. So we should be able to get my grand total here. 120, yes. So hopefully my column values over here are going to add up to give me that as well. So let's see, 40 plus 20 plus 10 would give me 70. And then 20 plus 15 plus 15 will give me 50, and that is adding up to 120. Remember, this is what we refer to as a contingency table. So this is my observed frequency data. This is the data that was actually collected. Now, what I've set up here, this is your expected frequency values. Okay, so this is where I guess we have to decide, do we want to run through the whole thing by hand, or are you just wanting to do it technology? Okay, Libby. You want to do it by hand? Okay, sure. So let's do it. So I'm going to get a calculator out here so I don't have to just keep going back and forth, okay? Because I have not worked this problem previously, and I don't know what all we got here. So let's say I want the expected frequency value for the number of males, all right, who play Batman based on the data. So how do we find the expected frequency values? Okay, Gabby says 60 times 70 divided by 120. All right, that's exactly right. For that particular cell, you take the column total times the row total, and you divide by the grand total. So let's see, what do we got here? 60 times 70 divided by 120. I'm getting 35. Is that what you guys are getting? Okay, I got 35. And now let's go with volleyball, but now that we're in a different cell, this time it's going to be 35 times 70 divided by 120. What am I getting now? Now let's go ahead and round it, let's say to 2 decimal places. Okay, I got 20.42. And then table tennis, 25 times 70 divided by 120. Okay. Somebody want to help me out? Okay, perfect. And then now we're going to go through the second row, 60 times 50, 30,000. Or 3,000, excuse me, what am I saying? Divided by 120. I got 25 on that one. All right, 35 times 50. Okay, so I got 14.58 again. Well, that makes sense because we got the same values. And then 25 by 50 divided by 120. So this one I'm getting 10.42. Would you guys agree? Okay. So any questions on how I got any of those 6 values? We're good to go. Okay. Well, now, we'll come back to these in just a second. What's H naught? That's the null hypothesis. H sub 1? The alternative hypothesis. Okay. So we'll come back and we'll write those sentences in just a second. Let's go ahead and fill in this table here. So we've already got the 40, 20, 10, those numbers. So we're going to go in order. So the expected frequency for 40 came out to 35. And then we got 20.42, 14.58. Remember, the cells have to correspond. So for 25, that should go with the 20 that we had right there. Then 14.58, and we'll finish up 10.42. Okay. So now I want to take the difference of them and square them. So this one I kind of just shortened the table a little bit. So this one here, 40 minus 35 squared, that'd be 25. And then 0.42, well, it's a negative, but that doesn't matter. 0.42 squared. Now, do you want me to go ahead and continue to round to 2 decimal places, or? Okay. So this one I'm getting 0.18. You guys are confirming with me on the calculator, right? Because it's very possible I could make a mistake. I haven't gone through this problem yet. Okay, because 20 minus 20.42 should be a negative 0.42 times negative 0.42, 0.18. Okay. And then 10 minus 4.58, or it would be a negative 4.58. I'm getting 20.97, or 98.
Yes.
20.98. Okay. Then I'm getting another 0.18. Oh, I skipped to the next one. I'm sorry. Okay. 0.18 here. Then that one's going to be another 25. Okay. And then this one here. I'm getting another 20.98. Is everybody okay with that? Everybody would agree? Okay. So I took the difference, I squared them, and now I'm going to take these squared differences and I'm going to go ahead and divide by the value. So 25 divided by 35, let's say 0.71. Okay. Then 0.18 divided by 20.42. Now this one we're going to have to go a little bit further because I got 0.0088. So do you want to go ahead and take these to 3 or 4 decimal places? So go 3? Okay, so I'm going to make this 0.714. So this other one will be 0.009. How sad is it that would it have been awesome if it had come out 7? Y'all know what I'm talking about, right?
Yeah,
Okay, because a lot of people were just looking at me. I'm like, I'm not that old. Okay. All right. What do we do now? 20.98 divided by 14.58. I got 1.439. Okay. 25 divided by 25, I got a 1.18 divided by, oh, it's the same. Oh, it's not the same. 14.58. 0.012. So far, so good. And finally, 20.98 divided by 10.42, 2.013. Is that what I got? And let's get that sum. 0.714 plus 0.009 plus 1.439 plus 1 plus 0.012 plus 2.013. I'm getting 5.187. Cool. 5.187. Okay, so this right here, okay, is my chi-squared calculated value, 5.187. Now, what we're going to need is the critical value. There were 2 items that helped me do that.
The degrees of freedom.
Okay, now what are the degrees of freedom?
It's the column minus 1 times the number of rows minus 1, right?
That's right. Okay, so the number of columns minus 1 times the number of rows minus 1. Yep, so we have the 2 minus 1 is 1, 3 minus 1 is 2, so that's absolutely right. So this should be 2 times 1, which is 2. Now, we do have a decision to make. We have 3 different percents for my significance level that we could run with.
Let's do 1%.
You want to do 1%?
Sure, why not?
Okay. So let's test it at 1% with a degree of freedom of 2. Now, I don't have that pulled up. Does anybody have that chart? 9.21? Okay, so if we decide at 1% with a degree of freedom of 2, okay, our chi-squared critical value, he said 9.21? Okay, so now let's compare the two. 5.187, 9.21, well, that's definitely less than. Now, we wanted ours to always be what? Greater than. So this means what? They are independent. So the way we'd say that we do not reject the null hypothesis. Okay, we say that they are independent. And in fact, let's take a look at this real fast. We're talking about gender and let's just say sports choice. Okay, whatever that is. What would you say for the null hypothesis?
Gender is unrelated to
Or remember, what's the vocabulary we want to focus on? Independent and not dependent. So, I mean, just something straight to the point, like maybe gender and sports choice are independent. Okay. Gender and sports choice are independent. Okay. And then for the null hypothesis, I mean the alternative hypothesis, excuse me, it's basically the exact same thing, but one word. What word do you want to add? Not. So gender and sports choice are not independent. Yeah, right today. And those quotation marks just so I don't have to write the whole thing over again. Okay, good. Now, any questions on this? Hey, Libby.
So where exactly did the critical
Now, that comes from a table that's already been prepared for us. You go ahead and do it. Well, I'll go ahead and pull this up real fast. Let's see here. Is this? From the notes, we were given a table where the rows were the degrees of freedom. and the columns were the significance level that we could choose. So let's see here. Here we go. So if we take a look, the reason Spencer gave me 9.21 is because, let me get a marker here. See, we had degrees of freedom of 2, and we chose 1%. So we want this guy right here.
And why did we choose 1%?
We just happened to choose 1%. I mean, really, you've got 3 choices to make, 1%, 5%, and 10%, and you can choose any of the 3 you would like. Now, let's see, because we've talked about this before, what was my critical value that we got? It was 5.18. Okay. So if I come back over here, 5.18, if I'd chosen 5%, would I have still gotten the same outcome? Okay, yes, because it's still less than 5.99, but if I'd chosen 10%, would it have shown there's a relationship? Yes. You remember we were talking about this last week. Really going with a higher percentage is just kind of in a way giving yourself more leniency, more leeway, so that maybe you could get the outcome you're hoping for. But if you're going to go more specific like we did, we're showing there's no relationship. Okay. There's no association at all.
So is this like if we're trying to disprove something, most likely we would go with the lower frequency experiment?
Yeah, if you want to disprove it, then I would go with the more specific one. Yeah.
But like if it's like we're arguing for the other side of things, we put 10%.
Yeah. And people do that all the time, things like this, to go ahead and kind of make the data, say what they want. Because I mean, it is accurate. They just have to be, transparent about what they're doing to get that data. Emily?
So on the worksheet, if they don't give you exactly what it is, you just go to that board figures. So
I think on the homework, didn't I give you the significance level on all of them? Not on the second one? Let me see.
it says what get that
Oh, no, it gives you 10% significance level.
right. So we use the
So you're going to use the 10%, and then you just have to calculate whatever the DF is. And then you'll be able to figure out. So it's one of those columns.
right? Give it as
Oh, okay, yeah. And that's sometimes what will happen. Sometimes the problem will actually just go ahead and give you DF, even though, I mean, it's very easy to calculate. Sometimes it'll just go ahead and give you the significance level. But on the exam, they have to give you that information. Yeah, because there's no way we're going to remember this table. Okay, Libby.
Also, I have one more question. When we were filling in the chart
Uh-huh.
of like SPA,
Yes.
I got the SPA based on those numbers, the 40, 20, 10.
Oh, because, see, they have to match up. See, we found the expected values. Remember, this is where we were multiplying, like, to get to 35, we multiplied 60 by 70 and divided by 120, right? So we're looking for, basically, think about it like corresponding cells. In this first one, in row 1, column 1, we had 40, so I want to make sure the expected value goes right with it. See, right here, 20, okay, should match up to the 20.42.
Yeah.
Okay. Does that make sense? Okay. All right, well, now let's see how well we did. Let's go ahead and take all this information and put it in the calculator real fast. So help me remember these numbers: 40, 2010, 20, 15, 15. Okay. So how do I do this? I'm on my scratch pad. Okay, so this button right here. And what are the dimensions of my matrix? 2 by 3. Remember, don't worry about the row column or the row total column, that is, or the column total one. Okay, so I'm going to have to choose this one because we want 2 by 3. Okay, 40, I want to say 2010. And then it went 20, 15, 15. Okay, so you put in that size matrix. We go ahead and get out of the matrix with my cursor, and this is where we go ahead and store it. And I think, didn't we have some fun with this on Friday? Yeah, I stored it as Joker. Yeah, you can actually store it as a name if you want to. But however you choose to store it, you're going to hit Control and then Variable. I'll try something different this time. So B-A-T, or maybe I should go Bat Pumpkin. Okay, so Batman. So when I go ahead and type in Batman, typically, you know, especially for the exam, just type in a letter, but it's fun. Now when I type in Batman, it'll know this. So what do? Menu. Stats. Okay, then we want to go to stat tests. Two-way. We don't want GOF, the goodness of fit. That's a completely different test. So now it's going to ask me, okay, what matrix? BATMAN. Okay. And what did we get ours to be? We got 5 point, if we rounded it to two places, we would have gotten 5.19. Degrees of freedom is 2. Our p-value, remember the p-value was what you're going to compare to your significance level. So in this case, I'd go ahead and compare 0.07 to 0.01. And because the p-value is greater than, remember it's the reversed idea of what we want with the chi-squared calculated and critical, that's just another way to confirm we were correct. Okay, at 1%, we're showing that there is no relationship between the two. How would I pull up that expected matrix? Okay, hit the variable button. And then we want EXP matrix, enter. And aren't those the values that we were coming up when we did it by hand? There you go. That's everything we've been talking about when it comes to chi-squared. Okay, so we've now been on this a full week. Is this making more sense? Does anybody have any questions? Hey, Libby.
How do you get the bracket thing to stretch? Letter stretch.
To stretch. Are you talking about changing the size of the matrix?
Oh, this. So it's like, I want you to type it for.
Oh, no. Okay, so what you'll do is go to this button right here.
Yeah.
And see, they've already got some templates here for you, but any size matrix you want, you'll go to 3 by 3, and then you can just change it.
Okay.
Okay, good. All right, well, here's what we'll do. You've still got good like 25 minutes left in class, so hopefully that should be plenty of time. I'll just go ahead and turn you guys loose, finish up that homework. You've got your calculators. If you have a question, let me know. And then tomorrow we'll turn it in first thing. We'll get it graded, and we'll talk about the limitations. And I don't know, if we can get to it tomorrow, we'll go ahead and start talking about sets. But if not, we'll start that on Wednesday.
Okay.
Sounds good.